Thank you very much, and thanks for joining us, everybody, today. So I just would like to share with you some of the models that our partners over in Spain and France have produced for us. So I'm going to use the Alice term BGen throughout this. It's what we've been using for the last 3 years, but it really just means all these different terms that are used in different scenarios, nature-based solutions, ecosystem-based and initiatives, all these kind of different terms, we're just rolling into the one blue-green infrastructure, and the network is the extra point at the end, which ties everything together in one sort of joined up thinking model. So each model starts with the current situation, and the current situation is based on real data from the catchment that's been collected over the years, water samples, soil maps, topography, biodiversity, all kinds of different things, and then this is all built down into hydrology models and water flow. And this is compared to a business as usual future model. And so it's not necessarily a prediction, it's more of a continuation of current trends. It doesn't take into account, obviously, other activities that are starting and other groups are doing. It really is just the land use trends that are from satellite imagery over the last, well, since 95 to 2018. It's a continuation of current policy drivers, and then it builds in climate change models as well. And the outputs from these are really just an average, sort of a 10-year average of 50 years in the future. And some of the models will stop here. This can show opportunities. So obviously a local BGen intervention is unlikely to have any effect on things like solar radiation or total rainfall, but you can use these to show opportunities because it will highlight certain areas of challenge. So for example, rainfall, obviously, installing BGIs in these areas isn't going to affect the amount of water that falls in the catchment, but we can use it to show where there is a need for BGIs. So that this model at the bottom is highlighting that if rain increases, that there's going to be more of a challenge in these sorts of areas, and it's going to expand up into the middle and upper part of the catchment, and so BGIs which manage water are going to become increasingly more useful, and that will need to work together more as the decades go on. Other models then can progress into a future with a blue-green infrastructure network, a BGen future model. And this includes a set of BGens that we have added to the current situation, and it then diverts the future from the business as usual. And the model we have used includes riparian strips. It includes winter bird cover, water storage, peatland restoration, and tree planting. And there are lots of different assumptions around how much trees will expand in certain areas, topography, the soil condition, how all of these factors will be built into it. There are so many different models that have been produced. This is some of them. There's probably the same amount again. The ones on the left are more processes. They're simpler models. They combine fewer processes, and then these ones are interrelated, interconnected to produce much more complicated models on the right-hand side. And the starred ones are the ones I'm going to share with you here today. So what have we actually modeled in our BGen future? Well, we've not tried to produce an ideal situation, because an ideal situation is different for everybody. There are trade-offs for the landowners in terms of production, in terms of all kinds of different things between installing a BGen or not. So what we've done is we have placed BGIs, the water storage areas, the woodland planting, peatland restoration riparian zones along all the different rivers, and areas of winter bird cover. We've placed them where in every feasible situation. And we're not trying to say that we would impose this level of water storage in this area. It's just simply saying that this obviously looks like a key area where water storage can happen and have an impact. So what's important is not necessarily achieving all of this model, it's achieving buy-in, and this model is aimed at showing opportunity. So the first couple of models here then. So we're looking at total vegetation growth, which is a factor of several different things. It's the soil quality, the change in climate, temperature aspect, all kinds of different things. In the top part of the catchment, this obviously mainly refers to agricultural grassland. There's quite a lot of agricultural grassland for grazing up there. It's not as easy to show because it doesn't change from yellow to orange. It all stays at fairly the same level of productivity, but you can see lots of little grey patches. So in the business as usual, lots of the grey patches disappear and we move to more grassland because agricultural grazing grassland will become more productive, and there are fewer incentives or insufficient incentives to retain the trees. So the trees are being converted into grassland. Whereas in the businesses, in the BGen model, the trees are retained. There are sufficient incentives, and you can tell all these little yellow dots are farm areas of trees, and grazing obviously still happens. Grass is going to be as productive as the business as usual, but there's less conversion because of these tree retention incentives. So this is slightly different. So it's because it's total vegetation, it's not comparing grazing grasslands with grazing grasslands. It's more like heather growth up in the hills. It's rough grazing grass. So in the future, because of the increase in extreme drought and flooding events and the duration of those, we see a much reduced ability for plants to grow. So there's the potential for woodier, drier heather growth. There's a potential for rough grazing to be completely abandoned and that land not to be managed anymore. Whereas in the BGen future, planting trees, planting riparian zones, restoring the peat, slowing the water from draining, creates resilience against these climatic events. And so we have much improved grass growth and habitat productivity, habitat growth. The farm timber sort of similarly, the same sort of lines. The farm woodlands are retained, and there's incentives to increase them. So nitrogen leaching is the next model. So you can see currently it's a fairly moderate level everywhere, and in the future it's going to stay roughly the same, but in the top area of the catchment, we're looking at field level changes, really, where grassland has been increased, where woodland has been converted into grassland, and water is going to move more quickly, and it's going to take more nutrients off of the fields. And also, interestingly, in the lower end of the catchment, because of this reduction in grazing, there's less nutrients going onto the ground, and therefore many of the little dots many of the fields will turn yellow. Whereas in the BGen future, the whole catchment is actually improved, and this is a combination of obviously high in the catchment there is less intensive input, so there's less nutrients actually going into the ground up there, and further down the catchment there are more opportunities to capture those, so it actually results in a fairly uniform nutrient leaching throughout the catchment. And that translates into the rivers. So currently we're sitting at a moderate level of nitrate in the rivers, and in the future it increases to high everywhere. And in the BGen model, it actually reduces again to below how we are in the current situation. There are a few areas actually, it's very hard to see in the model because the rivers are so fine, but in many of the secondary rivers high up in the catchment, they actually go to some of the lowest levels of nitrate. Changing theme onto fire risk now. So this is it really does show a big change to do with climate because of increased radiation, longer, drier drought events, that sort of thing, and the whole catchment therefore increases from a fairly low to moderate risk to a uniform high risk. In fact, it actually increases to the same level that Spain are now, which is slightly worrying sometimes. So the top model is just risk. It doesn't actually take account of the vegetation, whereas the bottom model takes account of vegetation and soil type. It has a little bit more to do with aspect as well. So that's why the very top of the model, you can see the very top of the catchment, sorry, it's quite drumliny, hilly areas. So aspect has quite a big effect actually, especially in the summer when we have longer spells of sunshine, which is going to dry out these angles of the hills. But really the big clear picture is in the hill areas here. So currently we're fairly low to moderate risk. It's going to increase quite a lot, and this is a factor of several different things. It's the poorer growth of vegetation, the drier, woodier growth of vegetation, the potential for rough grazing to be abandoned, and therefore the land to stop being managed. And that really all adds up into quite a high risk throughout the hill areas. Then in the BGen future, we retain a lot more water in the hills. We have much better, lusher vegetation. We have retained grazing, which keeps the land under constant management, and all that works together to, although it does increase from the current situation, over the whole of the hilly areas pretty much, except for the really stony areas, which is what the yellow parts are. It's much lower than it could be in a business as usual scenario. Access is another theme that was looked at. Now, recreational demand. I've overlaid a black blanking out there of everywhere that is private land that really people can't access, because this model is to show people's desire to visit and explore an area, but it does also include driving through it and the desire to live in the area. But just first of all, the areas which we can definitely visit, we see in the business as usual a slight change in desirability to visit the areas, not really very much at all. But in the business as usual, in the BGen future, we see places like the Forest Park, areas around Newry. We see the peatland areas, actually, because of their increase in biodiversity, because they've been so well restored. These all increase in recreational demand as a term. There are a few areas that decrease, partly because of the potential for increased grazing and therefore maybe restrictions on public access. If we take away the mask, you can really see the effect of the benefits to reduced flooding. It makes many of the areas in the north and the west much more desirable to live, much more desirable to visit. Especially tree planting and riparian as well make the areas more attractive. So all of these potential benefits, where do we start? You know, we've built this huge map of all the feasible areas where all these different BGIs can go. We've built this feasible network where everything is linked together and it all sums into one big effect. We have our peatland areas, we have our scattered woodland and our potential riparian and storage zones. They really seem to fall into 3 or 4 specific spots where there are opportunities for particular BGIs to be targeted. So this really brings together all the different models into these different hotspots. So in the north of the catchment, it really does seem to be a good area for water slowing BGIs, things like ponds, trees and riparian, and especially as we move forward into the future because of this increasing value of installing BGIs there. In terms of well-being, we have a really big change in the potential for flooding in these big main rivers up here. And it's a really priority area as well for water quality improving because there's a lot of nitrate reducing potential in this area. In the middle of the catchment, we have this corridor almost, and it's again another good area for ponds and trees and riparian, which captures a lot of what's coming from this direction, from the hills. It also helps to maintain this culture of conservation throughout the whole catchment. It's not just a north and a south divide. It's, you know, it really helps to have this corridor to link. And in terms of nature, obviously corridors are very important in terms of linking habitats and linking feed areas, especially with winter feed crops. And in the south of the catchment and the more hilly areas, you know, we've really got this big need for fire risk reduction, a real priority area for wetting the area and slowing the water from draining from the hills in terms of riparian and ponds and trees. We also have, in terms of these being publicly accessible areas, around Ross Trevor, we've got an increase in recreational value in around that area. And in terms of biodiversity, it's a good area for improving the peat, which obviously these are all interconnected, and that's going to help with the fire risk as well. So it's a very simple summary for us of the types of BGIs that are, you know, probably key opportunities for these different areas. So in the north, we have our ponds, our riparians, our winter bird feeding and our trees. And down the corridor, we have very similar. We have the riparian, the winter bird feeding, the trees and the ponds. And in the lower end of the catchment in the hill areas, of course, we have our peat conservation, and we have our ponds and trees as well. And but yes, of course, you know, these are the hotspot areas, but it's getting buy-in that's important. It's these are opportunities. Anyone who will buy into these kinds of BGIs in these particular areas will create a benefit, and as more people buy in, it will produce more and more of a network. And so hence tomorrow's toolkit presentation, which brings together in one booklet what BGIs can do individually for the farm, what it can do for nature, what each one individually, what they can do for the community. It will give guides on funding BGI installations for the individual landowner, and who to talk to if you're interested in them. So yeah, hopefully that's an interesting set of models. It's so many to choose from, but hopefully that was useful for you.